It was past midnight in the laboratory, and the building was almost silent. Only one room still had its lights on. Inside that room, a young physicist stood in front of a strange machine made of metal, wires, and glass. The machine looked simple, almost harmless, but what it was about to show would challenge everything he believed about reality. On the table in front of him was a small device that could fire tiny particles of light, one at a time. In front of the device stood a thin metal plate with two narrow openings, like two small doors cut into steel. Behind that plate was a screen that would record where each particle landed. The experiment was simple, at least on paper. If the particles were solid objects, like tiny bullets, they should pass through one door or the other and leave two clear lines on the screen. If they were waves, like ripples in water, they should pass through both openings at once and create a soft pattern of many lines, spreading and overlapping like gentle echoes. For years, scientists had known something strange. When no one watched the particles as they passed through the doors, they behaved like waves. They acted as if they were many things at once, moving through both openings, creating a pattern that no solid object should make. But when a detector was placed to observe which door each particle went through, everything changed. The wave pattern disappeared. The particles behaved like solid objects, choosing one door, leaving only two simple lines behind. It was as if the particles knew they were being watched. The physicist had read about this experiment many times. He had studied it in books, seen it in diagrams, heard professors explain it in calm voices. But tonight, he was not reading about it. Tonight, he was running it himself. He pressed the button and released a single particle. A tiny flash appeared on the screen. Then another, and another. Slowly, the pattern began to form. He stepped back and stared at the screen. Without observation, the soft wave pattern appeared again, beautiful and impossible. He felt a chill run through him. How could something act like many possibilities at once? How could reality remain undefined until someone looked? He swallowed and turned on the detector. Now the machine would watch the particles as they moved. Again, he pressed the button. Again, the particles flew one by one. This time, the pattern changed. The soft waves vanished. Two simple lines appeared, clean and clear. The particles were acting like solid objects. The room felt different now. The silence seemed heavier. He looked at the machine, then at the screen, then at his own hands. Nothing else had changed. The only difference was observation. The act of watching had changed the outcome. He whispered to himself, that should not be possible. And yet the evidence was glowing in front of him. The particles did not decide what they were until they were measured. Before observation, they were possibilities. After observation, they became facts. He turned off the detector once more. The wave pattern returned. On, two lines, off, waves again. It was not random. It was not a mistake. It was a rule of the universe. And in that quiet laboratory, a deeper question began to rise in his mind. If tiny particles change their behavior when observed, what does that say about the nature of reality itself? Is the world solid and fixed? Or does it remain open, fluid, and undefined until it is seen? He slowly looked up from the screen and stared into the empty room. For a brief moment, he felt as if he was not just watching the experiment, but participating in it, as if his awareness was part of the equation. The machine continued its silent work. The particles continued their strange dance between possibility and certainty, and somewhere between the flashes of light and the shadows, in the room, one simple, unsettling idea began to form. What if observation does not just reveal reality? What if it helps create it? The young physicist did not leave the laboratory that night. He sat in front of the screen, watching the quiet pattern of light, trying to understand what he had just seen. The experiment was not broken. The machine was not making mistakes. The results had been repeated thousands of times by scientists all over the world, and yet they still felt impossible to understand what was happening. He had to step into a world that does not follow normal rules, the quantum world. In everyday life, things seem clear and solid. A chair is a chair, a wall is a wall, a ball thrown in the air follows a smooth path. But at the smallest level of reality, the level of atoms and particles, the universe behaves in a very different way down there. Particles are not just tiny solid objects, they are described as waves of possibility. Before they are measured, they do not have one fixed position. They exist in many possible states at the same time. This strange condition is called superposition. It means that something can be here and there, moving left and right, spinning up and down, all at once. It is not that we simply do not know where the particle is. It is that the particle truly does not choose a single state until measurement happens. The physicist imagined it like a cloud, not a solid dot, but a soft cloud of possible outcomes. Only when someone checks does the cloud shrink into one clear result. In the double-slit experiment, this is exactly what happens. When no one checks which slit the particle goes through, it behaves like a wave. It spreads out, moves through both openings, and interferes with itself. The result is a pattern that can only be made by waves. But the moment a detector is placed to watch the particle's path, something changes. The wave-like behavior disappears. The particle acts as if it went through only one slit, as if it made a decision. It is as though the universe waits for a question before giving an answer, and the question is asked through measurement. The physicist leaned back in his chair and stared at the ceiling. If reality at its smallest level is not fixed, what does that mean for the world built from those particles? Every object, every tree, every human body is made from the same quantum pieces. If the foundation of reality is based on probability, then certainty may not be as solid as it seems. Some scientists explain this by saying that the measuring device forces the particle to interact with the environment. His interaction destroys the wave pattern. It is not about human awareness, they argue. It is simply about physical contact. Others are not fully satisfied with this answer. They wonder why the act of gaining information seems so powerful. Why does knowledge change behavior? Why does reality appear to shift when observed? The physicist felt both excitement and discomfort. He had entered science to find clear answers, but the deeper he looked, the stranger the questions became. The quantum world did not behave like a machine made of tiny gears. It behaved like something flexible, responsive, almost mysterious. In this world, certainty comes last. Possibility comes first, and observation stands between them like a gate. As the quiet hum of the laboratory filled the room, one thought stayed with him. If the universe, at its core, is built on possibility, then perhaps reality is not a finished story. Perhaps it is still being written. The young physicist returned to the experiment the next morning. The sun was rising outside, but inside the laboratory the questions still felt dark and heavy. The particles changed when observed. That much was clear, but something deeper was now troubling him. What exactly counts? As an observer, is it simply a machine that measures, or is it something more? He looked at the detector attached to the experiment. It was just a device made of metal and circuits. It had no thoughts, no feelings, no awareness. And yet, when it was turned on, the wave pattern disappeared. The particles behaved differently. Some scientists say this proves that consciousness is not required. They argued that any interaction with the environment is enough to collapse the wave of possibilities into a single result. According to this view, the universe runs on physical laws alone. No mind is needed. No awareness is involved. The detector simply interacts with the particle, and that interaction forces a definite outcome. It is mechanical, automatic, impersonal, but not everyone feels satisfied with that answer. Other thinkers have asked a bold question. If the detector records information, but no one ever looks at the data, has observation truly happened? If a result exists but is never known, is it fully real? Some physicists and philosophers have suggested that consciousness may play a deeper role. They wonder if awareness itself is the final step that turns possibility into fact. The physicist walked slowly around the machine, thinking. He imagined the particle as a wave of potential paths. He imagined the detector interacting with it, and then he imagined himself looking at the screen. At which point does the change truly occur? When the detector collects data, or when a conscious mind becomes aware of the result? This question has been debated for nearly 100 years. Great scientists have stood on both sides. Some insisted that physics should remain separate from the human mind. Others believed that removing consciousness from the equation left something incomplete. The physicists felt the weight of this mystery. If consciousness plays no role, then reality is fully independent. It unfolds the same way whether anyone watches or not. But if consciousness does matter, even in a small way, then the universe is not just a machine, it is a relationship, a dance between the observer and the observed. He looked at his own reflection in the dark glass of the laboratory window. For the first time, he did not see himself as separate from the experiment. He was not just studying reality, he was part of it. Every time he checked the results, he was participating in the process. The line between subject and object felt less clear. The experiment was no longer just about particles and waves. It was about the role of awareness itself. If the act of observing changes outcomes in the quantum world, even through physical interaction, then observation has power, and if awareness is connected to observation, then the human mind may not be a passive witness, it may be an active participant. The laboratory was quiet again. The machine waited. The particles remained hidden in their cloud of possibility. And one simple question echoed in his thoughts. Is the universe something we only watch, or is it something that responds when we look? The physicist could not stop thinking about the observer. If observation has power in the quantum world, what about the human mind itself? He left the laboratory and walked across the university campus. Students passed by, lost in their thoughts, looking at their phones, worrying about exams, planning their future. Each one carried a private world inside their head, and he began to wonder, what is the state of the mind when it observes reality? Is every mind the same, or does the quality of attention matter? Later that week, he visited a neuroscience lab. There, scientists were studying brain activity. Small sensors were placed on a volunteer's head. A screen nearby showed waves of electrical signals moving across the brain. The researcher explained something simple but powerful. When a person feels stress, fear, or anger, the brain waves look chaotic. They jump wildly. Different areas of the brain move out of sync. It is like an orchestra where every musician plays a different song. But when a person feels calm, focused, and emotionally balanced, something changes. The brain waves become smooth and ordered. Different regions begin to move in harmony. This state is called coherence. Coherence means alignment. It means the heart, brain, and nervous system are working together instead of fighting each other. The physicist stared at the screen, watching the patterns shift as the volunteer closed her eyes and slowed her breathing. Within minutes, the chaotic waves softened into steady rhythms. The change was visible, measurable, real. He felt a quiet realization begin to form. If observation matters in physics, and the observer is the mind, then the state of that mind may also matter. A distracted mind may observe differently than a focused one. A fearful mind may interpret the world differently than a calm one. The external world may not instantly change shape, but perception certainly does, and perception guides action. He imagined two people walking into the same room. One expects danger, the other expects opportunity. They see the same environment, but they notice different details. They respond in different ways. Over time, their choices lead them down different paths. The physicist began to see coherence as more than a brain state. It was a bridge between inner experience and outer reality. When the mind is scattered, attention is weak. When the mind is coherent, attention becomes strong and steady. And attention is a form of observation. He returned to the image of the double-slit experiment. Particles exist as possibilities until observed. Human life also contains many possible paths. The mind does not control the universe like magic, but it does filter experience. It selects what to focus on. It shapes decisions, and decisions shape outcomes. Perhaps coherence is the human version of clarity in the quantum world. A clear state that reduces confusion and turns potential into action. As he left the neuroscience lab, one thought stayed with him. If the observer matters, and the observer is the mind, then learning to bring the mind into coherence may be one of the most powerful skills a person can develop. The physicist began to test the idea, not in a laboratory, but in his own life. He had always been careful, cautious, and often doubtful. When problems appeared, he focused on what could go wrong. When opportunities came, he saw the risks first. He told himself this was rational. But now he wondered if his attention had been quietly shaping his experience all along. He decided to try something simple. For 1 week, he would observe his own thoughts the same way he observed particles. He would notice where his attention went. He would gently guide it toward clarity instead of fear. Each morning, he sat quietly for a few minutes. He slowed his breathing. He allowed his thoughts to settle. At first, his mind felt noisy and restless. Worries about work, doubts about the future, small regrets from the past. But instead of fighting those thoughts, he simply watched them. Slowly, the noise became softer. He felt moments of calm, small but real. During the day, He noticed how often his mind expected negative outcomes. When an email arrived, he assumed it carried bad news. When someone looked serious, he assumed they were upset with him. These were not facts, they were interpretations, and interpretations guide behavior. One afternoon, he received a message from a colleague asking to meet. His first thought was that he had made a mistake in his research. His chest tightened, but this time, he paused. He chose a different focus. Maybe the meeting was about a new idea. Maybe it was something positive. When he entered the office, he was calm instead of defensive. The conversation turned out to be an invitation to collaborate on a new project. He realized something simple but powerful. His old expectation would have changed his tone, his posture, his words. It might have shaped the entire interaction. Attention does not magically move objects across the room, but it changes perception. Perception changes emotion. Emotion changes behavior, and behavior shapes results. Over the next few days, he noticed more patterns. When he focused on problems, they seemed larger. When he focused on solutions, his mind became creative. Ideas appeared that he had not seen before. It was as if attention acted like a spotlight in a dark theater. Where the light shines, the scene becomes real and vivid. Where there is no light, details remain hidden. The world had not physically changed. The university buildings were the same. The people were the same. But his experience felt different, lighter, more open. He began to understand that even if quantum effects stay in the microscopic world, the principle of observation clearly lives in human psychology. What we repeatedly observe in our thoughts becomes familiar. What becomes familiar feels true. What feels true guides action, and action builds the life we experience. Standing outside the laboratory one evening, watching the sun set behind the city, he felt a quiet sense of wonder. Perhaps the observer effect is not only a strange rule of physics, perhaps it is also a mirror, a reminder that the mind is not just a passive camera recording reality. It is an active lens, and the direction of that lens may shape more than we realize. The physicists returned to the laboratory one last time. The room looked the same as it had on that first night. The machine stood quietly on the table. The metal plate with two narrow openings waited in silence. The screen behind it was dark, empty, ready to record the next result. He turned on the device and watched as a single particle was released. A tiny flash appeared, then another. Slowly, the familiar pattern began to form. Waves were not observed. To clear lines were measured. The experiment had not changed. The rules were still the same. But he had changed. He no longer saw the experiment as a cold mechanical event. He saw it as a question that reached beyond physics. At the smallest level, reality begins as possibility. Only through interaction does it become definite. In human life, something similar seems to happen. Each day begins with many possible paths, different choices, different reactions, different ways of seeing the same event. Attention selects one path. Belief strengthens it. Action makes it real. He stood there, watching the tiny flashes of light, and felt a strange connection between the quantum world and the human experience. Maybe the universe is not a fixed block of stone. Maybe it is more like flowing water, shaped by structure, guided by laws, but still responsive. Not controlled by thought in a magical way, but influenced by observation through perception and choice. He thought about all the times he had assumed reality was solid and unchangeable. All the moments he had felt powerless, all the times he had forgotten that his response was part of the outcome. The experiment did not prove that the mind creates the universe, but it did reveal something profound. Observation matters, interaction matters. The role of the observer cannot be removed from the story. He turned off the detector and watched the soft wave pattern return once more. Possibility. Then he turned it on again. Certainty, back and forth, potential and decision, like life itself. As he powered down the machine and prepared to leave, one final thought settled in his mind. Maybe the greatest experiment is not happening inside this laboratory. Maybe it is happening inside every human being, every single day. Each thought is a form of observation. Each focus of attention highlights one possibility over another. Each decision collapses many futures into one lived reality. The building lights dimmed as he stepped into the night air. The city around him moved with quiet energy. Millions of people observing, choosing, reacting, shaping their paths in small but meaningful ways, and somewhere between science and consciousness, between particles and perception, A simple but powerful question remained: are we merely watching the world unfold before us? Or are we, in ways both subtle and profound, helping to shape the reality we experience?